Alright, we need to simplify this expression. I was thinking to myself, a student can do something crazy and I would not do, is they might want to change this into tangent using the quotient identity. Or, it'd be totally bad if they did something like you just cover up a 1 here and they thought they can do cotangent by the quotient identity. Remember, when you see the word simplify, you probably want to change them all into sine and cosines. What do you do, class, when you see simplify?
Sine over cosine.
Change them into sine and cosines. Now, I did give you guys a tip that 1 minus sine x is an expression, and you can't just break it up. It's kind of like together. Okay? Well, in order to subtract fractions like 1/3 minus 1/4, you would not do something like 3 minus 4 would give you -1 in the denominator. You need the lowest common denominator. The lowest common denominator in this case would be multiplying this side by 3 over 3 and this side by 4 over 4. Therefore, your common denominator would be 12. On this one, my common denominator is just multiplying these two. Okay? What does that mean? On this side, I'm going to multiply by 1 minus sine x. 1 minus sine x. And then on this side, I'm going to be multiplying by cosine x over cosine of x. I can multiply these two now. This is an expression, so this is like my first step, and then I'm showing that this first step is equal to or equivalent to the second step. Cosine times cosine is what? Cosine squared x. And then this is just cosine x 1 minus sine x. Now, it wouldn't be wrong to put this set of parentheses first. Just whatever order you pick, just be consistent. Over here, I'm going to distribute. I can multiply sine of x times 1 would give me what? Sine of x, and sine of x times sine of x? Yeah, that would be correct. So this would be a positive times a negative sine of x, so that would be a minus sine squared x. And then denominator, I have cosine x 1 minus sine x. Now, I could have taken care of that negative earlier. I could have said something like a negative sine x, but if you have a different color, definitely show this part there. Now I have cosine squared x. I'm going to distribute this negative sign. So I have negative sine x, and this negative or negative 1 or the opposite would be a positive sine squared x. Now we have a common denominator, so now I can put it under one fraction. Cosine x times 1 minus sine x. Now, a temptation of a student might want to be doing some cross-canceling. For example, they might think they see sine of x and a sine of x. They might want to try to cancel those. That would be incorrect because here you have subtraction. You can only cancel if it is by factors. Factors basically means multiplication. Okay, so you can only do like crossing them off if you see multiplication. Okay. Now I'm going to put these two together. Let's put those together. So all I did was just put them together. I can do that by the commutative property of addition basically means I can just change the order. Okay. Partner B tell partner A, why did I put the red ones together? And what do you think this red one means? I'll give you a hint. It's on your identity formula sheet.
Because on the big diagram, there's a sine squared and a cosine squared. Yeah.
Class, we're going to say the identity on the count 3. Ready? 1, 2, 3. Pythagorean identity. Class, all of this is equal to 1. So now I have 1 minus sine of x over cosine of x over 1 minus sine of x. Do you guys see anything? Yeah, if I put a parentheses around this, essentially this is 1 times this expression. So now we can cancel these two. Now be careful with canceling. Is the answer cosine of x? Remember, there's like a 1 here. A lot of students will kind of just say, okay, I cancel, anything left to have is cosine. It's incorrect. When you have nothing left in a fraction, you always have a 1 there. So right now I have 1 over cosine of x. And we can just make that really clean. Partner B tell partner A what's another identity we can use at this step. On the count 3, 1, 2, 3. Secant of x by which identity? The reciprocal identity. And that's my answer. So let's review. In this problem, they ask you to simplify the expression. They're just like fractions, have a common denominator. Try to combine them into one fraction. As you're doing that, you might see some identities as you go along. Remember, when you see the word simplify, you might want to start, in this problem we already had it, they're all in already sines and cosines.